Hey students, this is your hints video for lesson 9.2 on lines of fit. So for this first problem, we're going to look at this line and see whether we think it's a good fit for the data. And I would say there are too many, oops, let me get my pen going here. There are too many points that are below the line. And so therefore the line is not a good fit. If we count, we only have maybe one point that's above the line, and then all of these other points are below. So a better line of fit would be somewhere a little bit lower like that. All right, on this next problem, we're going to graph the data, and then we're going to come up with a line of fit. So we have our points that we're going to graph, so 0, 0, 1, 0.8, that's right here, 2, 1.5, 3, 2.2, 4, 3.0, and 5, 3.8. And then we have to look at the different pairs of points that were offered and see which one would give the best line of fit. So as we look at these options, we kind of have like the first and the last one, which since neither of them are outliers is probably a pretty good bet for us. The other ones, if we were to pick like these 2 points in the middle, depending on where those points are, the line could end up being like a little bit less steep than we would want it to be. Kind of depends. But in this case, neither the first nor the last is an outlier, so we'll just go with those 2 points. So once we do that, we're going to use those points to write an equation. So the first thing we're going to do is to find the slope. So 3.75 minus 0 is 3.75, right? 3.75 is the change in y, and 5 minus 0 is 5. We'll use our calculator to simplify that, and we get 0.75 is the slope. Now, since it goes through the origin, the point 0, 0, our best line is y equals 0.75x. We can use that equation to predict the weight of 10 pints of blueberries. So pints is x, so when we have y equals 0.75x, we're going to substitute 10 in place of x, and we get y equals 7.5. So that would be about 7.5 pounds. For the last part, it says blueberries cost $2.25 per pound. Use the equation to predict how much 10 pints of blueberries will cost to the nearest cent. So if it's 7.5 pounds, we're going to multiply 7.5 times 2.25, and we get about, well, we get exactly 16.875. Of course, we want to round that to the nearest cent, so that's $16.88. All right, our next problem is showing the temperature compared to how many hot chocolates are sold, and we want to pick the graph that best depicts the data that we have. So we have, let's see, the lowest temperature is 30 degrees. Okay, so temperature should be on the x-axis, right? So both of these scatter plots kind of include all of the points we want, but we want to have temperature on the x-axis, hot chocolates on the y-axis, so that we have the point 30, 45, and that's right here. So this one right here seems to be our match. Now, we want to find a line that could best approximate the points here, the line of fit. So we want to pick which of these data points, which pair, would give us the best information. So we have 3 choices, and We can eliminate this last one because we don't have a data point that's 90-15. So we wouldn't want to include a data point that's not part of our scatter plot. So then we just have these two choices. We have 36-43 and 80-10. So that's like this point and this point, which now that I've circled them, it's a little bit hard to see, but those points are both like a little bit on the low side, right? We can see especially this point, 36-43 is just kind of lower than the rest of them. So that's probably not the best point to choose. Instead, if we go with this point, 30-45 and 60-30, those points are kind of right in the middle of the action. So those would be our best bet. So now that we've picked those points, we can write an equation using those points. So we're going to figure out the slope. So let's see, we can do the change in y. 45 minus 30 is 15. 30 minus 60 is negative 30. So that slope is negative 1/2. And then we can kind of approximate, if we were to carry this line up, we would see that our y-intercept is somewhere here in the positives around 60 or 70. And we can use our points to figure out exactly where that is. So we have the point 60-30, and then we have the point 30-45. So as we're moving, if we move 30 points to the left, 60 minus 30 is 30, we move 45 points up, right? We go from 30 to 45. So if we were to continue this, we would have the point, I'm going to write it over here, 60, 30. If we go over another 30 to 0, we would have to go another 15 points up, so that would be 0.60. So our line would be y equals negative 1/2 x plus 60 is our equation of our line of fit. And then we just have to fill in some information about our slope and our y-intercept. So the slope is negative 1/2 or negative 0.5. The y-intercept is 60. So you could predict that 60 hot chocolates are sold when the temperature is 0 degrees, and that sales increase by about 1 hot chocolate for every 2-degree increase in temperature. And then we can predict the number of hot chocolates sold when the high temperature is 20 degrees. So we have our equation y equals negative 1/2 x plus 60. We're going to use negative 20 as our x value, or not negative 20, positive 20. So that's y equals negative 10 plus 60. We would expect to sell about 50 hot chocolates if the temperature was 20 degrees. All right, and then the last one I put on here, there are several problems where you are going to be asked to use a graphing calculator. You're going to go to Desmos.com. Oops. Desmos.com. And I just copied down here what's in your notes for lesson 9.2. You're going to enter the data regarding ticket sales into Desmos by clicking on that plus sign and choosing table. You're going to enter your data, and then you're going to choose the line of, you're going to create a line of best fit by writing in this equation. Remember, you're going to do y1, you're going to use that little tilde sign, and then mx1 plus b. It's going to tell you the equation of the line of best fit. It'll tell you what the slope is, what the y-intercept is, what the correlation coefficient is.